Let's Science is brought to you by the StarQuest Production Network and is made possible by our many generous patrons. If you'd like to support the podcast, please visit sqpn.com/give.
3, 2, 1.
We live in a universe of scientific wonders.
Every day, scientists are inching towards breakthroughs which can change our lives.
We're playing our small part in sharing these wonders with you.
That's why today is a fine day for science.
So let's science.
I thought today we would talk about an article that I found it was originally published in The Conversation in 2021 in November, and it was then republished at space.com, a favorite source of mine, by the way, for science topics, because there are so many good articles here. This one is about the moon's top layer. It says the moon's top layer alone has enough oxygen to sustain 8 billion people for 100,000 years. So I thought I'd talk about that today and explain how the science of this how this has been discovered. So first of all, it says here that alongside advances in space exploration, we've seen much time and money invested in technologies that could allow the effective space resource utilization. And at the forefront of this is obviously how do we produce oxygen in space, in different environments in space. And a couple of episodes ago, I did a discussion about producing oxygen on the moon. The Mars rover has a device attached to it that has been producing very small quantities of oxygen on the moon, which is really cool. But sorry, not on the moon, on Mars. However, the moon is the most likely destination of human beings with the Artemis missions that are coming up, which almost launched but didn't launch, will hopefully launch this month. So what they're thinking is we want to set up a permanent human presence on the moon. And to do that, we need to be able to produce oxygen on the moon. So the moon itself has an atmosphere, but the atmosphere is made up of hydrogen, neon, and argon, which is not the mixture of gas that could support any human life. However, they say that there is actually a lot of oxygen on the moon, as I hinted at in the headline of this article, but it's just not in gaseous form. It's trapped in what's called the regolith, which is the layer of rock and fine dust that covers the moon's surface. And what they propose here is that if oxygen could be extracted from this regolith, it would be enough to support human life on the moon. At least that's the theory. So I want to mention also, and this is really cool, that Australia gets a mention here, the Australian Space Agency. They've actually signed a deal with NASA to send an Australian-made rover to the moon as part of the Artemis program. So I would say that's not part of Artemis 1, it's most likely part of Artemis 2. And its goal is going to be to collect lunar rocks that could ultimately be used to produce breathable oxygen on the moon. So a couple of things about this. So oxygen is found in minerals all around us on the Earth. And the moon is made mostly of the same rocks that you would find on Earth as well. So there are minerals such as silica, aluminium, and iron and magnesium oxides that dominate the moon's landscape. As a side note, Jerry, I just want to point out that I said aluminium, which might be jarring for some of our listeners because I think they say aluminum. Does that sound about right? Is that how they say it in America?
I've heard of it being pronounced like that, yeah.
Yeah,
so like battery and battery.
Yeah, exactly right. Yeah. So if anyone's a bit jarred by me saying aluminium, that's just the way we do it around here. But I'm talking about good old US aluminum. Okay, that's what I'm getting at.
Talking about Coke cans.
Yeah, it's exactly. Yeah, that's it. Yeah, that's what. True. So all of those minerals I just listed contain oxygen, but obviously not in a way that our lungs can actually process. It needs to be converted to a gas. So what it says here is that on the moon, these minerals exist in the forms including hard rock, dust, gravel, and stones that cover the surface. And so the material released from these come from the impacts of meteorites that crashed into the lunar surface over thousands and thousands of years. Some people call it the Earth's or the moon's version of soil, but it's not soil in the way that we understand it. It's actually, so obviously we have soil. We're very fortunate to have that because it's one of the things that keeps us alive. Soil is basically the work of organisms that work on rocks, digest rocks and process and whatever else, and it becomes soil. Now, regolith is what you have before organisms do their work on rocks. So what we then have is a matrix of minerals which were not present in the original rock. So Earth soil is imbued with, its remarkable physical, chemical, and biological characteristics, whereas the materials on the moon are basically the original untouched form. So they believe that the moon's regolith is made up of approximately 45% oxygen, but that oxygen is tightly bound into the minerals as mentioned above. So in order to break apart those bonds and release the oxygen as gaseous form, they require energy. Now, if Caroline was here, she'd be able to explain this to us, but they need a process called electrolysis, I should say. And this is commonly used in manufacturing to produce aluminium or aluminum. And what happens is basically an electrical current is passed through a liquid form of aluminium oxide called alumina via electrodes, which separate the aluminium from the oxygen. Now, on Earth, the process, the byproduct of producing aluminium this way is oxygen. Now, on the moon, the oxygen would be the main product and the aluminium itself would then be the byproduct, which would be very useful because it could be used to construct other things on the moon. So although it's a very straightforward process, what they're saying here is that there are some catches. One catch is that the machinery itself requires vast amounts of energy. So what they're theorizing is that could they use solar energy, on the moon in order to power machines? The other option, the other complication is that these machines are quite large, and we would have to get them to the moon's surface. So maybe take the parts there and have them constructed on the moon. So moving that equipment is also a big challenge as well. So it says here we have the technology to do it. It's just getting there and having the energy to run it. Now, in 2021, Belgium-based startup Space Application Services announced it was building 3 experimental reactors to improve the process of making oxygen via electrolysis. And they expect to send this technology to the moon in 2025 as part of the European Space Agency's in situ resource utilization, or ISRU mission. So, that would be really cool to see how that all works out. So lastly, how much oxygen could we get out of the moon, potentially? Now, I've already talked about it in the headline, but let's go through the science of this very quickly. So scientists believe that there is a lot. There is a large, vast amount of oxygen that could potentially be released in the moon to make it to have a breathable habitat there. So it says if we ignore the oxygen that's tied up in the deeper hard rock material of the moon and just consider the regolith alone, the estimates say that regolith contains 1.4, each cubic meter contains 1.4 tons of minerals on average, which includes about 630 kilograms of oxygen. Now, NASA says that humans need to breathe 800 grams of oxygen a day to survive. So 630 kilograms of oxygen from 1.4 tons of minerals would keep a person alive for just over 2 years by estimate. So it says, now let's assume the average depth of the regolith is about 10 meters, and that we can extract all of the oxygen from this. This means that the top 10 meters of the moon's surface would provide enough oxygen to support all 8 billion people on Earth for about 100,000 years. So the answer is a lot. There's a lot of oxygen there. So it would depend on things like how effectively it was managed to extract and use the oxygen. But they reckon, obviously, that this figure is quite amazing. Now, oxygen would also not just be used for humans to breathe, but oxygen is also part of the mixture of rocket fuel as well. So potentially launching rockets as a fuel source straight from the moon there's possibilities there as well. So it concludes by saying, having said that, we do have it pretty good here on Earth, and we should do everything we can to protect the blue planet and its soil in particular, which continues to support all terrestrial life without us even trying. So there it is, Jerry, the science of producing oxygen on the moon. Now, if there was oxygen on the moon in habitats, do you think you'd go for a visit?
I'm sure. Yeah, sure, I would.
Just go.
If I didn't have to, wear a hazmat suit or a moon suit.
Yeah. Yeah.
I could say, just going for a walk outside.
Yeah, I'm going for a stroll on the moon.
Outside my moon hotel.
Yeah, that's right. I wonder how many people. If that,
we can explore the gardens.
That's right. Yeah, the moon rocky gardens. Yeah, I just wonder if how many, like, if it became a touristy place for people to go, how many people would walk out and step on the moon for the first time and say, "That's one small step for man," while everyone just rolls their eyes and like occasional tour guys going, "Yeah, we've never heard that one before."
You're so original.
Yeah, wow. Did you make that up yourself? Where did you hear that? Yeah.
Yeah, I like that story because a lot of the times when you hear about stories about populating the moon or visiting the moon, it's all about the getting there, which is obviously a pretty critical step in doing so. But I always had it in my head that when we're going to land on the moon, if we ever stay on the moon, it's going to be something like, say, the International Space Station is. It's going to be a dedicated, fenced-off area where
absolutely
you can't get out and it's all self-contained.
Yeah.
But what this is talking about is actually harvesting what's there on the moon as opposed to, bringing your own oxygen.
That's it.
Bring a backpack of oxygen, bottle of oxygen, bottle of water.
Yeah.
It sort of talks about the sustainability of such a project, which, to be honest, we're not going to be able to keep sending rockets every time we want to do something on the moon. If it does end up getting populated, it needs to be able to look after itself, long term.
Yeah.
And so it did talk on here about the use of solar energy, which, clearly that's probably the, given the thinner atmosphere and all that is probably something you would certainly look to start to doing, is something that can run autonomously, not something that needs machinery or mining or something to be able to continue. So let's go bad question time.
Yep.
So obviously if we're going to use solar energy on the moon, so is there I suppose the question would be, is there a perfect spot to put this so you get sun all the time? So given that the Earth rotates around the sun, and then the moon rotates around Earth, and we only see the same face of the moon.
Yes.
So does the moon's rotation plus the Earth's rotation mean that there is a spot that's always sunny on the moon?
Right. That's a good question. So I don't know the answer to that. But
no, Lindsay doesn't know the answer to this because it's out of the blue.
Yep.
So just same as the listeners, Lindsay's in the same boat as you. I didn't tell him or plan him or anything like that. So So we'll go to the answer.
Yep.
So if this sounds like a trick question, it is.
It is a trick question. Okay.
And the reason we can tell this is because we know that Earth only sees the same portion of the moon, right?
Yes. Yes, that's right. Yes.
And so because we see a full moon, we see a gibbous moon, which makes me think of monkeys.
Yes. Yep.
Etc. Because we're only seeing that, we're only seeing where the sun's hitting on the moon.
Of course. Yep.
So there is actually no good spot on the moon because we get a day of 24 hours where we get darkness and light. The moon's orbit, what the moon sees of the sun, because we see it goes over a month.
Yes.
But there is no one spot on the moon that gets sun all the time.
Yes, right. So they'd have to problem solve that somehow as well. I wonder if
it'd be like night and day, except night and day would be a lot longer on the moon.
Yes. Yeah. Yeah. Exactly right. Yeah, thank God scientists have to work that out and not us. Yeah. I wonder if, they've talked about in the future, and I don't know how this would work, but they talked about, for example, nuclear-powered rockets being the future, because obviously, fuel rockets are not going to, it's not a sustainable industry in the long term. I wonder if having some source of nuclear power on the moon, getting it there, again, is a massive challenge, but I wonder if that's the stopgap. So that you've got a combination of this source of energy, solar energy, whatever other energy they might devise in the future. I just wonder.
We should just have elevators.
Yeah, that's right. I need a space elevator. That's all. Yeah, that's it.
And every time the moon comes past, okay, you got to go on now. Otherwise you're going to miss you.
Get on now or you're going to miss the moon. Yeah, you have to come back tomorrow. Yeah. I'm going to run. I'm going to catch a space elevator. Yeah. That's awesome.
Let's Science is brought to you by StarQuest Media and is a fortnightly podcast that brings you the scientific wonders of our universe from a distinctly Catholic point of view. For more from Caroline, Lindsay, and friends, listen to the StarQuest show, Catholics of Oz. Find links from today's show at sqpn.com/science and find the Catholics of Oz at sqpn.com/Oz. Be sure to follow the show in Apple Podcasts, Google Play, wherever you can find podcasts, or on the SQPN YouTube channel. The generous donations of our patrons at sqpn.com/give make it possible for us to continue Let's Science and all the shows at StarQuest, which makes our nonprofit mission possible. You can join them by visiting sqpn.com/give. Join us next time for more scientific wonders, and thank you for listening to Let's Science on StarQuest.